Have you ever thought about boarding a plane that doesn't roar to life with the deafening sounds of the engine, but instead hums smoothly as it travels off the runway? A plane that leaves no carbon footprint, yet flies faster than ever before? This isn't science fiction. It's the brand new levitating train that Japan is aiming to create. With innovative designs, advanced engineering, and big challenges still ahead, the real question is, how close are we to experiencing this futuristic way of flying? But wait, this groundbreaking project comes with a jaw-dropping price tag, around $50 billion. Stick around, because we'll be diving into just how much this high-speed marvel is going to cost and what hurdles still stand in the way. Japan, a large country, is struggling with congestion issues, which are causing increasing problems in its transportation networks. The travel routes experiencing the most congestion are those connecting Tokyo, Nagoya, and Osaka. Apart from being geographically close, these three cities are very important for Japan's economy. Tokyo, the capital city, acts as a financial center. Nagoya is famous for manufacturing, especially in the automotive sector. And Osaka is a colorful city that is rich in culture. The interconnectedness of these three cities demands smooth travel in order to sustain economic growth. However, the economic activity as well as rising population has resulted in chronic congestion in these areas. Millions of passengers travel back and forth between these cities, which has put great strain on the existing transportation infrastructure. As the population continues to grow, the demand for faster and more efficient travel options has become increasingly clear. With around 37 million people living in Tokyo alone, the existing transportation system struggles to sustain an influx of commuters. The current Shinkansen B bullet train is almost always full of passengers, which is a terrible experience for all the passengers. In order to combat these issues, Japan is currently building its first high-speed maglev or magnetic levitation line. This ambitious project is designed to connect Tokyo and Nagoya by 2027, providing a faster and more efficient travel option for commuters and travelers alike. Additionally, plans are in place to extend the line further to Osaka by 2037. It all began in the 1970s, an era marked by increasing congestion on the major travel routes between Tokyo, Nagoya, and Osaka. The Japanese government recognized this issue, which ultimately resulted in research focused on developing cutting-edge technology that would revolutionize travel experience. During that era, the engineers decided to work on developing a new rail concept capable of operating seamlessly without any issues. The main goal was to develop a kind of bullet train that would transport the passengers from Tokyo to Nagoya in under 40 minutes, which would eventually extend to Osaka in just over an hour. These efforts gave birth to Shinkansen, the maglev we talked about earlier. Unlike normal trains, the maglev system operates using powerful magnets to lift the train above the tracks. By removing friction, the maglev system allows trains to reach speeds never seen before. The Shinkansen went through its testing phase in 2013 over a dedicated track, where engineers developed this technology further. The testing phase was not easy at all, as it was full of challenges from ensuring safety to optimizing speed and efficiency. But the engineers worked tirelessly to address all the challenges thrown at them. If we talk about the construction of the Shinkansen, it's nothing short of an engineering marvel. Spanning an impressive 286 kilometers, nearly 90% of this route will be meticulously tunneled underground, winding its way through both mountainous regions and bustling urban landscapes. However, with great goals comes great responsibility. The engineers needed great precision and creativity in order to combat the engineering hurdles that they had to face while cutting through such varied terrains. The project officially kicked off in 2014, but the path forward was not without its bumps. The high costs associated with this project has raised several eyebrows and concerns. Building a network capable of harnessing the power of magnetic levitation demands specialized materials and advanced technologies, which all add to the financial burden. The project was expected to cost around $55 billion. However, this estimate has since risen to approximately $55 to $66 billion. largely due to unforeseen engineering challenges, inflation, and complex tunneling requirements. Japanese taxpayers are being asked to cover a significant portion of the hefty $66 billion projected costs for the Maglev project. In 2016, for example, the government, under Prime Minister Abe Shinzo, provided JR Central with $20 billion in low-interest long-term loans from state funds. Additionally, local governments and taxpayers are covering the expenses for constructing new Maglev stations. According to JR Central, the average cost of station buildings is $236 million, with some stations, like Kanagawa's, costing as much as $1.4 billion. Despite these high costs, JR Central's president has acknowledged that the Maglev might not turn a profit within Japan itself, but will mainly serve to promote Japanese technology abroad. The costs are expected to grow even further in the future, especially with the extension planned to connect with Osaka. This makes Maglev one of the most expensive mega projects worldwide. Talking about the operational mechanics of this marvel, Japan's Maglev system is a showcase of cutting-edge technology and innovative design. The train traveling through the tunnels, bridges, and underground tunnels would be able to travel at a jaw-dropping speed of 500 km/h. At this point, it genuinely feels like this train defies the laws of physics. Most of this ambitious construction will be nestled underground, with about 90% of the route built below the surface from the starting point all the way to the first major city. Instead of disturbing the already bustling life above, the Maglev trains will travel underneath it, creating a seamless traveling experience. But the fun doesn't stop there. Some parts of the tunnel will go over 1 kilometer deep, making it the deepest railway in Japan. As Japan is known for its seismic activity, earthquake resilience is a topmost priority for this project. Each aspect of the infrastructure is built to withstand nature's forces, with advanced technologies monitoring for any movement or instability. The materials used for construction feature high-strength steel and specialized concrete that not only promise durability, but also provide resistance against the unusual movements of the Earth. When discussing the risks associated with this groundbreaking project, there are considerable concerns about its economic and environmental implications. For example, while many supporters are impressed by the project's clean energy potential, the fact that the train will actually use 3 to 4 times more energy per passenger than the current Tokaido Shinkansen cannot be ignored. And this energy would primarily be sourced from nuclear energy or fossil fuels. Other than that, a significant portion of the journey, 90%, will be underground, with 70 kilometers running beneath the untouched Japanese Alps. This extensive tunneling is generating massive amounts of waste, including dirt contaminated with toxic chemicals like arsenic and mercury. It's estimated that the construction between Tokyo and Nagoya alone will produce around 56.8 million cubic meters of soil. Since only a small amount of this can be reused, most of it is being dumped into gorges and river valleys, raising fears among experts and local residents about potential landslides during heavy rains. Additionally, there are concerns about how the tunnels might affect local water supplies. A survey by JR indicated that the tunnels could reduce water flow into the Oi River by 2 metric tons per second, alarming residents who depend on the river for their livelihoods. In fact, Shizuoka Prefecture's Governor Kawakatsu Heita has withheld approval for Maglev construction in the area due to these concerns. Additionally, the electrical power requirements for the Maglev trains are anticipated to be 3 times higher than those of conventional Shinkansen trains. Given Japan's current tight energy situation due to the shutdown of nuclear plants, this could create challenges during peak summer demand. The president of JR Tokai, Yoshiomi Yamada, has highlighted that the line's future energy supply depends significantly on the revival of nuclear power generation in Japan. Another major risk involves the potential eruption of Mount Fuji, while the Maglev train's design, which levitates above the tracks, reduces the risk of derailment. Most of the new line will be underground, running through a region prone to major earthquakes. Additionally, about competition between the Maglev line and JR Tokai's existing Shinkansen services. Approximately 60% of passengers on the current Tokaido Shinkansen from Tokyo disembark in Nagoya, while only 40% continue to Shinosaka. The planned one-way fare for the Maglev between Tokyo and Nagoya will only be 700 yen higher than the current line, leading to fears that passengers might choose the newer, faster option, potentially resulting in revenue losses for JR Tokai, which relies heavily on Shinkansen operations. While the Maglev project is currently facing numerous hurdles, once it does successfully implemented, it promises to be a groundbreaking innovation, not only for Japan, but also for the rest of the world. Once operational, the Maglev train will redefine high-speed travel, significantly reducing commute times between major cities and potentially inspiring similar transportation advancements globally. As Japan works to overcome challenges like environmental issues and financial constraints, it stands to gain valuable insights from this ambitious project. The experiences gained from the Maglev train initiative could serve as a guide for future infrastructure projects in other countries. If you liked this video, don't forget to like, comment, share, and subscribe to our channel. Also, turn on the notifications so that you don't miss out on more mega projects.